This is video number 2 for section 6.7 and 7.1, more examples of the factoring method. Let's go ahead and look at a couple other examples in this video. Here is another equation where we're being asked to solve for x. What I see, what pops out to me, is the exponent, solving equations with an exponent like 2 or 3 or 4. This particular equation is called a cubic equation since the highest exponent is a 3. Let's try to use the factoring method to solve this equation. Remember, there's that preliminary step about getting rid of any fractions or parentheses first. In this particular example, I do have a fraction. It's in my way, and so I want to clear the fractions. I do that the same way we've always cleared fractions. I find the LCD, which in this case would be 3, and I multiply both sides of the equation by 3. Of course, on the left side, I have 3 over 1, the 3's cancel, and so this gives me in the end x cubed equals 9x on the right side. Okay, no parentheses, no fractions, now I'm ready to go. I would say a very tempting, incorrect next step that I see a lot is people want to divide both sides by x here. Maybe that sounds like a nice thing to do, but that's bad algebra. Remember, in math you cannot divide by 0, and it's possible, since I don't know what x is, it's possible that x is 0. So I cannot do that. I have to follow clearly the steps in the factoring method. The next step is not a division step, it is a subtraction step. I need to get a 0 on one side, and that's going to be accomplished by moving that 9x term over to the left. And so now I have the equation x cubed minus 9x equals 0. I could have moved the x cubed over, but as we talked about in the last video, I really prefer my lead coefficient to be positive. Okay, now that I've got the 0, I can go on to factoring. The factoring would be useless without the 0 because of step 3. Let's go ahead and factor. Step 1 of factoring is pull out the GCF. In this example, I do have a GCF of x, leaving me with x squared minus 9. And remember, factor means fully factor. You don't stop until there's nothing left to do. I pulled out my GCF. Now I count my terms. I've got 2 terms. We only learned a handful of methods for dealing with 2 terms. The most common one was called difference of squares, and that's what this is. I've got a difference, I've got a subtract. X squared is a perfect square, 9 is a perfect square, and so that's the one that factors a plus b, a minus b. The a would be x, and the b would be 3, the items being squared. A plus b, a minus b. Okay, now this left side is fully factored. Once it's fully factored, I can go to step 3 and I can use that zero product principle. Now, this one is a little bit different than our other example because this time I have 3 pieces that are being multiplied together. I have the simple x, I have the x plus 3, and I have the x minus 3. Well, the zero product principle works no matter how many items you're multiplying. I mean, I could tell you I have 10 numbers that I'm multiplying and the answer is 0. That still tells you that one of them is 0. So any of these 3 items here could be 0, and that's what I need to write down next. Maybe the x is 0, or maybe the x plus 3 is 0, or maybe the x minus 3 is 0. I write down all the possibilities, and then I can isolate x in each case. You'll notice that in this problem, I'm going to end up with 3 answers. This x is already isolated, the 0. In the second guy, I would subtract 3 from both sides. In the third guy, I would add 3 to both sides. And what I'm going to end up with here is x equals 0, x equals negative 3, or x equals positive 3. We are saying that all 3 of these numbers are solutions to the original equation, and you could check that if you wanted to. It is common that with a cubic equation, where the highest exponent is 3, it is common to have 3 answers to the equation. Okay, let's look at a second example then of the factoring method. This particular one, what kind of pops out at me, I guess, is the parentheses, because we said we're never going to get anywhere in these things if we've got parentheses or fractions. So I would go ahead and, before I really did anything else, I would get rid of those parentheses. That's going to give me 6x squared minus 8x equals -2. Of course, now I see that this is a quadratic equation because the highest exponent is a 2. I know that normal algebra steps are not going to help me here, so I will try the factoring method. Step 1 of the factoring method, get that 0 on one side. So I will move this 2 over to the other side. Let's write down what we get. And now I can begin my factoring. Step 1 of factoring, pull out the GCF. I do have a GCF. It is the number 2, leaving me with 3x squared minus 4x plus 1. But I don't stop there. I'm expected to factor completely. I count my terms in here. I've got 3 terms, which means, again, this is either a reverse FOIL or an X box. It looks very easy to me to do reverse FOIL, but if you want to do X box, go ahead and pause the video and do that. But what I notice is 3x squared, there's only one way to make that, 3x times x, and then when I look at the back, the number 1, that's about as easy as it gets. There's only one way to make that, and that's 1 times 1. I just have to figure out, can I make a -4 in the middle here? Let's see, the outer would make a 3x, the inner would make a 1x. I should be able to make a -4 using a 3 and a 1. I would just need them both to be negative. So -3x and -1x makes -4x. So we've got it. We figured out the factoring. Now that I have fully factored the left side, I can go ahead and use that zero product principle. Once again, I have 3 items here on the left that are being multiplied together, and the answer is 0. You have to think about what the zero product principle says. It says if you do that, one of these 3 guys then has to be 0. Well, this time, I know that the first one is definitely not the 0 because it's just the number 2. 2 is definitely not 0. So that leaves me with only the other 2 as a possibility of where the 0 could lie. Maybe you thought we were going to get 3 answers again. That's not going to happen. For one reason, this is a quadratic equation. You'll never have more than 2 answers in a quadratic. And for another reason, again, the number 2 cannot be my 0. The last time we had an x out here. Well, I don't know what x is. Anywhere where there's an x, yeah, maybe that's where the 0 is. But if it's just a number, you can ignore that number. Okay, isolate x, and we're going to be done. This would be adding 1 and then dividing by 3. And the other guy would just be adding 1, and so it looks to me like my 2 final answers here are positive 1/3 or positive 1. Again, it wouldn't be too bad to take these numbers one at a time, plug them back into the original equation, and make sure the equation turns out to be true. You'll have plenty of opportunity to practice the factoring method on the homework.